This is Jaswinder from SWA. A very good day to all participants. Welcome to today's webinar organized by SWA and Fluence Corporation. Today, we will share with you what is MABR, what is the difference between MABR with other solutions, understand the advantages and benefits MABR brings. Finally, Fluence Corporation will share with us on their experience on many MABR-based wastewater treatment projects installed around the region. Okay, before we get started, I'll take a few moments to go through the usual drill. Some of you are familiar with it, but let me go through quickly. Okay, firstly, to ensure a smooth session, please mute your microphone and turn off your camera. If you have any questions in the chat, please type in the chat segment towards the end of the presentation. Do identify yourself. I will be recording this session and reserve the rights to the video. And end of the presentation and Q&A session, there'll be a post-event survey. So please do give your feedback. Disclaimer, all information shared is for general information only and does not contain or convey any legal advice or administrative assistance. Information shared today is true and accurate as of publication date. SWA and Fluence Corporation Limited reserve all rights in the provided materials. We'll be recording this webinar on the online video platform. It will be shared and kept as long as it serves a business purpose for the association. By attending the webinar, you're giving your consent to this recording. Now, without further ado, I'd like to invite Ms. Carol Huang. She is the marketing manager with Fluence Asia to give us a welcome address. Over to you, Carol. We can't hear you, Carol.
Yeah, okay.
Okay, good.
Thank you, Jess. Hello, everyone. And this is Carol from Fluence for Marketing Communication in Asia. And it is glad to welcome all of you to participate in today's session for our Smart MABR solution. So Fluence joined SWA actually last December and was introduced during Orientation Day event, but it is never too late to introduce us again. We are actually a global team of expert and professional passionate about developing our innovative and sustainable water technologies. Our company specializes in providing plug-and-play, high-quality and cost-effective water and wastewater treatment solutions that can be quickly installed, automatically operated, and easily maintained. Earlier before in 2017, Fluence entered the Asia market, and we now have around 240 installation references in Asia. Previously, in January this year, we have conducted an webinar session on Decentralized Solutions on water and wastewater treatment, which has aroused a lot of interest of MABR solutions. So this time, it is glad to invite our Israeli expert Gilad again to deeply introduce our MABR technology and solutions here to all of you. I believe you will get valuable takeaways after the session today. So let's get a start. Thank you.
Thank you very much for the welcome address, Ms. Carol Huang. Now it gives me the pleasure to invite our keynote speaker for today, Mr. Gilad Yogev, Senior Product Manager for MABR Products with Fluence Corporation. Over to you, Gilad.
Thank you, Jas. Thank you, Carol. Let me share my presentation here. Bear with me.
Okay. Okay, good.
Okay, you guys can see the presentation?
Yes, great. Yes.
Perfect. Okay. So, hi everyone. Hello again from Israel, and welcome to today's webinar about Fluence's MABR Smart Product Solutions. My name is Gilad Yogev, and I'm the Senior Product Manager of MABR Products for Fluence. And what we're going to speak about today is how Fluence packs MABR in multiple smart product packages and solutions, and what technologies MABR successfully competes or um, deals with, a little bit about alternative technologies. And we're going to look into some case studies of plants around the globe with all of Fluence's different applications, including results and lots of interesting stuff packed in today's webinar. First, I'd like to thank Singapore Water Association team for the opportunity to present and for the great hospitality as usual. So without further delay, let's get going. Okay, so we're going to start out with a little bit of history. As we all know, aeration is the primary energy consumer in wastewater treatment plants and wastewater treatment in general. And over the years, aeration has been aeration technologies have significantly improved, and the energy efficiencies have increased up to starting from the 1950s and going to the early 2000s, 90s, early 2000s with fine bubble diffusers. So the concept that has been well practiced in the industry is that you use a blower and you drive air through a body of water 4, 5, 6 meters deep, and you bubble bubbles into that wastewater and or a liquid, and depend on or rely on mass transfer for oxygen to get to the bugs and treat the wastewater. So that concept, as a matter of fact, hasn't changed throughout the past 80, 90 years. You just went, better with the technology, improved the the energy efficiency, but the same concept has prevailed throughout the past 90 years. And what we want to do with MABR, what we are doing with MABR is revolutionizing that concept. So no more bubbling air into a wastewater, no more huge blowers, but what we do is we introduce the air and the oxygen in a molecular phase through a membrane at an extremely low pressure. So just to put some numbers into context, in terms of aeration efficiency, so fine bubble diffusers provide around 1.5 to 2 kilogram oxygen per kilowatt hour, while MABR, we've seen aeration efficiencies up to 2 to 5 times higher than those. So this is a really quiet revolution that's happening here in terms of energy and aeration efficiency. But the real benefits of MBBR are much wider, and we'll see that in the next few slides. So Fluence's MABR is unique in its simple design. We use flat sheet membranes with a very simple plastic-based water and air spacer. Those both provide structural strength, and they optimize the air and oxygen mass transfer to the biofilm. So you can see the structure here on the top image. It's basically a double layered membrane sheet with a very simple net, a plastic net air spacer, just to provide optimal conditions for the air transfer through the membrane sheet. And on both sides, you have a water spacer, which enables water and mass to flow through the membrane spiral and have contact with the biofilm. So that very simple concept is inside our membrane, our technology. And the biofilm thickness, which is a question that we get frequently, the biofilm thickness is actually very well controlled because we intermittently mix the module with a very simple coarse bubble diffuser array that's situated under the modules. That's very, very, very simple, non-clogging, non-maintenance system that gives a gentle shake to the biofilm and sloughs off most of the excess biofilm. And actually what you see in that process, what we've observed in some of our installations, is an increase in the nitrifier fraction of the wastewater. So I'll explain that, okay? Usually in activated sludge systems, you have 5 to 7% nitrifier fraction inside the wastewater itself. That's the population that's prevalent, and you use process calculations. You calculate the process according to that nitrifier fraction that dictates your HRT and SRT in the system. MABR, because it's a biofilm system and the aerobic biofilm is very, very active and full of nitrifiers, up to 30–40% sometimes. That excess biofilm that sloughs off, that drops off, actually enriches the wastewater with a larger population of nitrifiers. So we've seen an increase in nitrifier fraction in the bulk wastewater, where you usually have 5 to 7% of nitrifier fraction. So back to the structure, we have a 50 millibar pressure inside the membrane. That's a semi-atmospheric pressure. You blow through a straw with a little bit of a resistance, and that's basically the pressure that you have inside the membrane. That's much lower than other technologies and other MABR competitors as well. So all in all, that makes MABR the most energy efficient nutrient removal technology that there is out there in the wastewater treatment world. A little bit more inside the process, and I'll start explaining about how this really works. You have on the left side the air side, the inner part of the membrane, and on the right side you have the wastewater side, the water side, and the biofilm is here in this nice gray drawing. So oxygen diffuses from the left side to the right side, and in this case ammonia diffuses from the wastewater to the inner part of the biofilm. Nitrification happens and nitrate is produced as a result. That nitrate diffuses out of the biofilm because that's a natural flow of nitrate. It's a much larger molecule than oxygen, so it can diffuse back into the membrane layer. So it diffuses out to the bulk wastewater, and in the presence of BOD, of carbon source, it is immediately denitrified into nitrogen gas, and that's how you get simultaneous nitrification, denitrification, and two distinct ORP conditions in the same basin. And I'll explain about the ORP, the oxidation reduction potential. You have very high ORP and aerobic ORP on the very base of the biofilm because you have an unlimited supply of oxygen. And as you gradually go out from the biofilm to the bulk wastewater, the ORP decreases, and it's somewhat, we'll see it in graphs later, but it's somewhat slightly negative. And in the first MBBR stages, almost even anaerobic. So those both support a denitrifying process that happens in the absence of oxygen. So now we're going to go even deeper into the process, and this is the last deep dive that we have. Traditional biofilm processes such as RBCs, MBBRs, IFASs, any other biofilm technology that you have out there, which were considered revolutionary 20 years ago, they have a very specific diffusion mechanism, and actually that diffusion mechanism is true for almost any type of existing wastewater treatment. It's called co-diffusion, and by co-diffusion I mean that both dissolved oxygen, right, the electron acceptor, and BOD or ammonia, the electron donor, they both come from the same direction, from the bulk liquid, and they reduce together as you advance into the biofilm itself. So the left side is a bulk wastewater, the right side is the base of the biofilm, and the biofilm thickness is on the x-axis. And you see they both decrease rapidly when you enter the biofilm, and pretty much at the middle of this biofilm, in the middle of this, the x-axis, you can see that they're very low dissolved oxygen and BOD concentrations. And as we all know, when we model processes with kinetics, monokinetics, this dictates a very, very slow reaction rate. And as a matter of fact, this area, okay, the base of biofilms in MBBR, RBCs, whichever other biofilm process, this area of the biofilm is considered a dead biofilm, a non-functional biofilm, and only acts as sort of a support. So MABR uses a counter-diffusion mechanism. That's what happens as an inherent part of the process. And by counter-diffusion, I mean that the electron donor and electron acceptor, they both come from separate directions, from opposite directions. You can see dissolved oxygen coming from the membrane side, okay, a very high, as I said before, a high ORP condition happening on the very top, on the very base, sorry, of the membrane. And in this case, BOD, or it can be ammonia, or it can be any other pollutant, coming at a concentration from the bulk liquid and being treated when it goes into the biofilm, and then reducing to a very low concentration inside the biofilm. Now, this counter-diffusion mechanism maximizes the ability of MABR to hold, as I said, two different conditions, two different ORP conditions inside one biofilm. You have high strict aerobic conditions inside on top of the membrane, on the very base of the membrane, and very low ORP conditions in the bulk liquid. You have a high dissolved oxygen, a low concentration of BOD, and ammonia diffuses in freely, and you get a very, very rapid nitrification process happening. And on the opposite side, on the bulk liquid side, you have a very high BOD level, but a very low dissolved oxygen level, which allows you to have denitrification happening. So this is what stands in the base of the MABR process and why it's so efficient and why it can do total nitrogen removal in one basin as opposed to other processes that you would typically use two basins. So after discussing the differences between MABR's biofilm and other biofilm processes, let's talk about the membrane. So usually when people first hear about MABR, they think it's a filtration process like MBR. I spent around 30 minutes on a webinar explaining what the difference between MABR and MBR is, but actually it's completely different. So the membrane in MABR is only there to act as a means of oxygen transfer and biofilm support, as opposed to MBR processes where you actually filter out the sewage through the membrane and leave all the solids on one side. So that inherent difference between membrane filtration and membrane biofilm processes is what causes the membrane lifetime of MABR to be much longer than membrane filtration processes. We talk about a 20-year lifetime expectancy and guarantee 15 in all of our products. This is as opposed to 3 to 7 years in MBR processes, which after those you have to replace the MBR membranes. Another important point is that there is absolutely no CIP, scouring, extensive chemical cleaning, biofouling, recovery cleaning, nothing of that associated in MABR processes. We like to say that we love them as dirty as possible. MBRs indeed do provide a very high effluent quality, but that is with the cost of replacing your membranes much more frequently, having a much higher energy requirement because you have to drive all that fluid through the membrane and scour and clean, and you have a high chemical consumption for MBRs as well. So that's the difference between membrane filtration, MBRs, and MABRs, membrane biofilm processes. That's a very, very important point to point out. And if you keep that in mind together with the difference between counter-diffusion and co-diffusion, you can really understand the value proposition of MABR properly. So going forward to a qualitative comparison between technologies, here's a little table to summarize. Starting with A2O processes, anaerobic, anoxic, oxic processes. large amount of wastewater treatment plants worldwide operate in A2O, CAS, conventional activated sludge. So A2O processes, if operated properly, they can provide a good effluent quality, but they are energy extensive and prone to SRT nitrifiers, washout sometimes due to storms. Nitrification, denitrification is generally a tough process to control in low temperatures or lack of carbonaceous material. And all of what I just mentioned leads to a complex process control, which is requires you to have a skilled operator, a good crew, and sometimes even a good crew doesn't help you in cases where there's a SRT washout or some sort of a problem in the process, and then you have to start up the plant, and it's a very, very long time to recover from an incident like that. So MABR can easily fit into A2O plants, into the anoxic zone, which I'll show in one or two more slides. And actually, you are saving on energy, you're improving total nitrogen and total phosphorus removal, and you're canceling any internal nitrite recirculation that you have from the aerobic to the anoxic basin. In general, you're simplifying the plant's operation. And important to say that MABR doesn't have any added maintenance to it. The membrane itself, if it's fed with air, air comes in, air comes out. There's an automatic mixing process happening, and that's it. You don't have to do anything to the membrane to make it work. And total nitrogen removal is part of the process itself. So that's the greatness of MABR and how it can really come into handy when you want to upgrade an existing A2O plant. So going to two other competing technologies, MBBR and MBR. So MBBR-based processes can be a very good solution for nitrogen removal, but just like A2O, they need two separate basins to complete the total nitrogen removal cycle. MABR does that in one basin, and as a result of the counter diffusion mechanism that we discussed earlier, energy-wise, there's also a very important point to make. In MBBRs, you have a continuous roll pattern that you have to apply in order to keep those carriers mixed. That's a continuous airflow that's consuming high energy. And lastly, the carriers themselves, they're prone to washouts. And if the screens aren't properly maintained and properly installed, or if there's some sort of a storm, you have a carrier washout, and you, as a matter of fact, lose a very large amount of your biomass, and that is a killer to nitrogen or nutrient removal plants. So lastly, MBR, which we discussed just one slide ago, has a superb effluent quality, a very high total nitrogen removal potential, but you have all those add-ons and all those adders in terms of maintenance, in terms of capex, in terms of membrane replacement, which all lead to a life cycle cost that is sometimes up to twice as the life cycle cost of the MABR. So having said that, having comparing to other technologies, it is important to say that MABR can combine and fit into any one of these technologies. And I'm going to show you some examples of how we fit it in with A2O, with MBBRs, and with MBRs, and actually enhance their capacities and sort of took out the good parts of each technology. Just an example, A2O. So we have a plant in Israel called the Maayan Tzvi wastewater treatment plant, where we upgraded our first line some year and a half ago and added 20% nitrification capacity to that treatment line with only 2.2 kilowatt of installed power. So that's a significant advantage to A2O. And this is the Maayan Tzvi plant that I'm speaking about. We're now entering the second upgrade stage. The basins actually had been treated for nearly 10 years. So the installation process actually included basin cleaning, other works, installing new diffusers in the aerobic area, upgrades. This was a very large project for Fluence at the time. Overall, we installed 11 Subra MABR modules inside the existing anoxic area of this basin, the left basin. And currently MABR, that line is treating between 67 to 75% of the total influent, while adding 20% more nitrification capacity to the plant. This is probably our best example of a successful A2O plant upgrade with MABR, and you can see that we're consistently exceeding the effluent quality. So moving to a completely different scale and a different application, we partnered with a company, great company called Orenco, great friends, great people over there in the northwestern US. Orenco is an FRP tank manufacturer, also a very successful small wastewater treatment plant manufacturer. And we partnered together to this project to supply an MABR-based system for a RV park, recreational vehicle park in Oregon. And this project was unique in many ways, the location, the application, but also the process scheme. So Fluence supplied our MABR modules in this case, and our partner, Orenco, supplied a fifth chamber with MBBR carriers. So what the MABR process does in this case is reduce the total nitrogen to a level that the MBBR only needs to do aerobic polishing. And as we know, biofilm-based systems, aerobic biofilm-based systems are very rapid at removing BOD. So we are able to treat a 42,000 GPD flow with this single unit, 4 MABR modules and one small MBBR chamber, and we're able to meet a very low total nitrogen requirement required to discharge to the environment. This is a direct discharge to the environment. So all in all, we see a very successful partnership between MABR and MBBR in this case. Lastly, MBR, which I sort of tackled to its high energy consumption, but in areas where a very high effluent quality is required, for instance, for non-potable reuse, we have a unique product that utilizes MABR and MBR in one product. So we call this the Spiral UF. This is an MABR MBR process, taking sort of the best of each technology. You see outstanding effluent results here in this table, ammonia of under 1, of extremely low turbidity, and very, very good parameters that can lead to potential reuse. So this has been installed in several locations in America, and there are a few more systems out there being prepared for projects. So to sum up the comparison, MABR has several inherent advantages due to the process and the diffusion method to the biofilm. Otherwise, it can be combined with other technologies in order to maximize the treatment efficiency and get the best out of each technology, which you've seen in the past 3 slides. So a side comment, or going back to the technology, to the MABR technology, what I want to point out is that MABR is indeed a very new technology in the wastewater treatment world, but it's been validated and proven in over 150 physical installations and over 260 ongoing projects throughout the world, and that's only Fluence. So this number isn't typical to a technology-based solution that's celebrating 5 years just this year, especially in our industry, where we know innovation takes a very long time to materialize and to commercialize. Our technology was validated for Title 22 reuse in the US. It's licensed in multiple states, validated in China, in the Philippines, in other regions. We work closely with Black & Veatch on multiple projects, and they're actually validating our installation in Mayansvi in Israel. And this is the reason, all of these are the reasons that back in 2019, MBBR was chosen as one of the top 10 water tech inventions of the decade by GWI. So a comment about decentralized systems. You all know that Fluence believes and aims for the decentralized market, and decentralized solutions hold multiple advantages. We already went over them in the last presentation, but I want to point out that Fluence has a wide range of decentralized applications, and we can go both directions if needed. I'm going to present a semi-centralized application in a moment. It's considered a small-scale centralized plant, but you can see that MABR can be considered for projects even if they're concrete-based or centralized, or just to point out that Fluence doesn't only supply MABR in 40-foot containers. So the degree of decentralization here rises as you go from centralized upgrades or new plants to our smallest member of the family, the spiral micro. Okay, this is our product portfolio, which is presented here in a more through view. Starting from the spiral micro, as I mentioned, a single home unit through package plants, 40-foot and 20-foot package plant containers, building blocks to form a large wastewater treatment plant. We can go up to 2,000 cubic meters per day with containers, containerized-based solutions. Modules, standalone modules that can be supplied to manufacturers, as we've seen in Oregon. And the two larger applications, super plants and super upgrades, in this case, Cambodia, which we're going to see in a moment, and Bayansvi, which you saw in Israel. So I'd like to discuss our most recent Subre plant here on the right side. And this Subre plant has been commissioned just last week, and the plant is in Sihanoukville, Cambodia. It's a first of its kind plant in the region, not to mention the first of its kind MABR plant in the region, but it's the first of a kind biological treatment plant in the region. Before that, the wastewater used to be discharged through an open trench, and now what we've successfully done is install a 7,200 cubic meter a day plant, which treats the wastewater to its outstanding quality and enables it to be discharged directly to the sea to protect the ocean and fish and all the environment in the area. So if you remember the previous webinar with the 80% global wastewater going out to the environment untreated, this is what I mean. This is what we are here for, and this is the real greatness of installing an MABR-based plant which treats nutrients in a very, very efficient way. And there's a short movie here to watch.
Located along the coastline, Sihanoukville wastewater treatment plant with the capacity to treat 7,200 cubic meters a day of domestic wastewater is
Sorry for that.
an important project led by Cambodian government to protect natural and living environment. The resulting effluent can be safely discharged back into the ocean without damaging the environment. The Sihanoukville wastewater treatment plant includes the innovative Israeli MABR biological treatment technology, in addition to pre-treatment and post-treatment. Which is composed of the innovative membrane aerated biofilm reactor, MABR system, and a clarifier, effectively removes organic compounds and nutrients containing nitrogen and phosphorus. Due to its unique method of passive aeration and treatment through biofilm, Fluence's MABR is a validated, stable, quiet, and environment-friendly technology for simple, effective, and energy-efficient nutrient removal.
Okay. So this is the plant that was commissioned last week. You can see the MABR basins, these 4 MABR basins, and whoops, there we go. Total of 20 MABR supermodules. So this plant, as I said, has been commissioned last week and is a big promise to the aquatic environment in the area. What I'd like to do now is present a few more case studies of our systems throughout China. I have somewhat some 3 minutes, and then we'll go to questions. So this was our first treatment system as part of a huge project in the Hubei region, partnering with iTest, which is a highway owner and operator. And each and every one of iTest's toll stations and stop stations has a Fluence MABR-based solution. So this was a old wastewater treatment plant that we actually built a new containerized system on top and utilized the existing basins. And you can see that it's an outstanding effluent quality that's returned to the environment at the end of this process. I'll send you guys, the presentation will be available to you all, so I won't go over all of the case studies now, but here's Sihanoukville again. I wanted to speak a little about our Philippines installations, which are starting to gain traction. There are 2 more concrete projects now happening in the Philippines, in the Manila area, and all in all, MBBR is gaining big track in the Philippines, and is a validated technology and actually spec'd in tenders for wastewater treatment in the Philippines because they understand the real need for nitrogen removal and are enforcing those tight total nitrogen and ammonia regulations. So all in all, MABR has over 260 installations worldwide. It's a validated technology, and it's probably your best choice for either upgrading an existing plant or installing a new decentralized plant. MABR is your choice, your best choice for a nutrient removal technology, and Fluence has all the ability to supply high quality MABR-based solutions to those needs. So with that, I'd like to thank everyone and go to the Q&A. Carol.
A big thank you to Mr. Gilad Yogev for sharing with us what is MABR compared to other traditional treatment processes, its advantages and benefits of this innovative technology, and how to treat the wastewater in a more efficient, cost-effective ways that be implemented around the world. Okay, Gilad, we have come to the Q&A sessions. We have a couple of questions there. Are you able to see the box, the Q&A box?
Yes, I can see both the Q&A and the chat.
Okay, you
so
click
what
on
do you
the
want to start
Q&A.
with?
Yeah, because some of the questions we have cut and paste into the Q&A box, so that will be the complete questions there. So the first one, okay, let me stop sharing, and I just tell you what the questions are. Okay, the first one is from Jason Wong. He says the question is, what kind of alpha factor is designed for the spiral wound aeration?
Yeah, I think technical questions, because it's a long answer. I think we'll take technical questions offline.
Sure.
I see we have a lot of technical related questions. We can answer all of them, but I think it'll be beneficial to tackle the more, I guess, general non-technical questions. Everyone will get an answer. Okay,
sure. We will send an email to you, the questions, and then we can send to Jason Wong and all the participants. Okay, the second one from Bhupinder Paudel. He says, what is increased CPAX and decreased OPAX factors of MABR compared to traditional bottom aeration system? In brackets, combining with need of extra mixer and sometimes extra scoring for biofilms. So is this technical too? So we can also, or you can
Yeah,
answer
we
that.
see, yeah. So MABR compared to, let's say, a traditional bottom aeration system or A2O system, usually up to 50% less. If you combine all of the extra mixing, it's not extra mixing, it's sort of can rely, as a matter of fact, on the same blower that the aeration, the wastewater treatment plant uses for the aeration system. So there's no real increased capex, and opex is up to 50% lower compared to the traditional systems.
Okay. Thank you. Okay, the third question is from To Yu Wei. Okay, the question is, how does MABR perform in extreme cold temperature, especially in those installations in northern China?
That's a perfect question. We have a nice picture of a MABR-based plant in the snow in northern China. Biofilm processes in general, and MABR in particular, and Fluence's MABR, just because of its structure, the biofilm itself has a protected environment. And there are lots of researches on how temperatures inside biofilms are sometimes 1 to 2 to 3 degrees even higher than the surrounding wastewater. So to put a bit of a proof on that, you're going to see in the next few conferences in Singapore Water, for example, you're going to see an analysis of plants and plants functioning by temperature. So we can go down to 10 degrees centigrade, even sometimes 8 degrees centigrade water temperature, and efficiently treat total nitrogen, nitrification and denitrification in wastewater.
Okay, thank you. Okay, we have last question here from Jason Wong. He says, okay, the question is, the excess biofilm that washes out of the membrane, is the dewatering of this MLSS difficult?
So it actually joins or combines into the MLSS of the system. We're speaking about a hybrid system, right? An MABR and activated sludge combined together, an A2O plant. Is the dewatering difficult? No, it actually improves the SVI of the plant. We see SVIs of under 110, sometimes even under 90 with MABR. And dewatering is just usual process. It doesn't impair the dewatering process, doesn't harm the MLSS in any way.
Okay, all right. Okay, we have this question from Mr. from a CK Theo, and the question is, the water and wastewater industry is very conservative. What are the challenges to encourage bringing about a change to an innovative product? Could you share some of your experience, especially on decentralization with new technology?
That's a perfect question for a product manager. So yes, we are in a conservative industry. We all know that. But when you show true value in terms of savings, in terms of operation, and in terms of life cycle costs, the decision makers already make the decision themselves to go to a decentralized solution and to an energy efficient solution such as MABR. We've seen that process happen in multiple cultures, countries, regions, from the US through South America to Eastern Asia, even places in Europe that are super decentralized, understand that hauling wastewater off in large pipes is not the what worked 100 years ago, and what everyone does since 100 years ago isn't necessarily applicable today, and they're much more cost-effective and life cycle cheaper on life cycle solutions. So we have, it's our job to educate the market on decentralized solutions. And when you go decentralized, the natural choice is to go with a technology that gives you value from your water, gives you the ability to reuse your wastewater and not just treat it and discharge. So MABR does all that. And it's our, as I said, it's our challenge and it's our mission. And the proof of that process succeeding is our multiple, more than 200 plants sold in China. And on the other side of the globe, there are projects that already specify decentralized systems and MBBR as a preferred technology, also happening in the Philippines.
Yeah. Excellent. Well said, Gilad. Yeah, you can see about 200 over projects you guys have done. That was fantastic. Okay, last two more questions. Then we'll go to the polling questions survey. Okay, this question has come from Emily. Okay, her question is there any MABR project reference for industrial WWTP?
Yes, so our plant in Israel, just because of the nature of the wastewater, has a oil press season around September, October. That's the oil press season in Israel, and we have, actually relates to the next question, we have incoming CODs of up to 30,000 milligram per liters. Obviously, some of that has to be treated with pre-treatment, right? But MABR successfully deals with those fluctuations because the biofilm is just a very, very robust process. And if properly adapted to those conditions, it can really successfully treat that industrial fraction of the wastewater. To the industrial reference question, a true or 100% pure industrial reference of MABR is not yet available in a factory or something like that, but we do have applications where we do side stream ammonia removal for plants. High ammonia containing streams, removing a significant fraction of that ammonia. And so that's something that we do. And the next WWTP, we're going to present a nice paper about pharmaceutical wastewater treatment with MABR. That's a pilot plant, so it isn't a full-scale plant, but really nice results from that pharmaceutical plant.
Okay, yeah,
I
sure.
hope that answers the question.
Yeah. So if Emily is more interested to know, she can write to me. Emily can write to me, and then I can introduce Gilad to you. It'll be fine, right, Gilad?
Perfect.
Yeah. Okay. Great. Okay. The last question. It's a very short one. Okay. It says it just says the question is maximum COD level.
Yeah. So it depends on the design. And I think that, as I mentioned before, we went up to 30,000 in the olive press season, but it really depends on the design and what you're looking for in the process.
Okay. Okay. Thank you so much, Gilad, for answering the questions. Okay. Here are some of the upcoming events. So do take note and join us. Thank you everyone for the survey. Okay, I was mentioning here the upcoming events in June. So do look out for us, our webinar. And once again, thank you to Mr. Gilad Yogev on answering the questions and doing the presentation. Ms. Carol Huang on the welcoming address for organizing this informative webinar with SWA. So before you leave, once again, thank you. And please visit our website for our upcoming events. Thank you and stay safe. We'll see you next time. Thank you.
Thank you. Thank you, everyone.
Bye-bye.
Thank you.
Thank you, everybody. Bye-bye.